Oh, hey Tim, what's up?
Oh, hi, Colin. Well, I was just reading this book. It's called The Science Book.
Ooh, looks interesting.
It is. I was learning about the different types of food. I don't know if you want to look over here, because all food has energy. But I was trying to think about what foods have more energy. So I have a marshmallow. This is a nice little snack. It's one of those peanut butter crackery things.
Love those.
This is a little bit of a chewy thing, a fruit chewy thing.
Ooh, chewy things?
Yeah, it's supposed to be a raspberry, but I had to cut a little bit of it off. Tastes good. These are Fritos, and those are almonds. I thought, we'll try something healthy in there. But I just didn't know which food would have the most energy. I know some of them are really sweet, right? So I think the marshmallow might be the sweetest. This one might have vitamins. I don't know if that means it has more energy or not, because maybe it has fruit in it. I don't know. But I was trying to read the book to determine how we could measure energy. You know what I found?
What'd you find?
Well, it seems that if you burn fuel, it releases energy in the form of light and heat.
Oh, does it?
It sure does. And it turns out that if you release energy in the form of light and heat, you can measure the heat quite easily with temperature. So I've got these thermometers, and I thought if we tried to measure the heat, but I'm smart enough to know that I can't just burn these and light the thermometer on fire. That seems bad. So I'm going to put thermometers in this water here. And I know it's colored. It's colored blue so that it's easy to see against the background. So I'm going to put the thermometers in the water and see which flame causes more heat.
Ah, so maybe we can determine which food has the most energy.
That's the idea. Well, are we ready to begin?
I think so.
Hey, Colin, what are the candles for?
Candles here to actually light our food samples on fire.
Oh, well, good. So what kind of food are we going to burn here?
Well, we're going to start off with 3 different ones. First off, I'm going to go straight to this marshmallow. I know it's going to burn easily. I light them on fire when I'm camping a lot.
Yeah, yummy.
We're also going to use the raspberry flavored fruit snack. And I'm starting with these 2 because I think that they're going to give off a lot of energy. I think maybe they have a lot of energy in them.
They're really sweet.
Yeah, they're really sweet. And we often think, hey, sugar gives me a lot of energy. I eat a bunch and I'm spazzing out for a while.
Yeah.
I think that'd be good. And the last one, we're going to use these nuts. And we're going to burn these.
Those are almonds, aren't they?
Yes, these almonds. We're going to try these out because I'm looking at, I think this maybe is the healthiest one. And I want to see what kind of effect that might have.
All right. Well, they all look like they're different sizes.
Yes, you're right. They do look like different sizes, but we've actually measured the mass of each food item, and they're all approximately the same mass.
Oh, okay, good. So let's light them on fire.
Yeah.
Hey, that's a pretty good little flame.
All right.
Okay, so that water is being warmed now. We'll put the thermometer in a moment. Gummy, I wonder if that's going to burn or that's just going to melt.
We will find out. Smells good though. Kind of.
Gummy looks like a fail. Is it burning?
Not really. Just
Okay, gummy fail.
all right. Marshmallow.
Marshmallows burn.
Yeah. You can hear it.
Wow, yeah.
Go. All right, I'm going to put our thermometers.
Yeah, put those thermometers in. Look at that big flame on the marshmallow.
And we actually have the same volume of water in each one. Let's try these registered trademark Frito-Lay's corn chips.
Yeah. Hey, that flame on the marshmallow is a lot bigger, but is it already out?
Looks like it is.
And it's a much smaller flame on the almonds, but it's still going. Those are the registered trademark Fritos from the registered trademark copyright Frito-Lay Corporation. That is a huge flame from the Fritos. There must be a lot of energy in there, Colin, because I see a lot of heat and
Combustion.
light.
I'm guessing.
Heat and light. And it's combustion. And what I like about this experiment is that when I think about what's coming off of there that's about to set off my smoke alarm, it's mostly carbon dioxide, water, and energy.
Oh, looks like that one is all done.
And the marshmallow won't burn anymore. So the marshmallow's totally not enough.
Let's try our peanut butter cracker sandwich.
All right.
Will it burn?
This is one of these little, getting a little scared of that Frito.
Yeah.
But that's a slow and steady flame on the almonds. Is the cracker burning?
It's starting to. It's really nice and charred. No?
You're going to get that flame going here.
Had it. There we go.
There it is. So, Colin, what's interesting is that smoke is unburned gases. It's fuel that didn't burn. It changed into a gaseous state, but it's not burning. So when we see that smoke coming off there, it means that the temperature of the flame is not enough to burn all the fuel. Boy, on the right, which one was that on the right?
That was the corn chip.
The corn chip, it's out, isn't it?
It is.
The almonds are still going. In fact, I think only one of the almonds has been burning the whole time.
Burning. Let's see if I can get that other one lit.
All right, because boy, that's really going, isn't it? But so the almonds have outlasted the corn chips and the marshmallows. And the gummy was just a fail; they just wouldn't burn. So that's the almonds again. You've relit them to get that second one going. That little peanut butter with the tiny little crackers. What do they call it? Ritz Bits registered trademark. That actually has a fair amount of energy. Do you think it's the cracker more or the peanut butter?
Well, I'm looking at the almonds, and they're nuts and peanut butter. Well, it's coming from peanuts.
Awfully the same. Yeah.
I'm thinking maybe it's coming from the peanut butter.
Could be. Listen to those noises.
If you look down here, you can almost see that water.
Oh, look. Is that steam?
So I've noticed that this actually started down here a little bit above 40 degrees.
Yeah. Well, it should have started. Actually, I probably started near 20.
Okay.
And look at where it is. Can you see that, camera? Yeah. It's almost. Look at it. It's boiling. And that is Dee's nuts. They are boiling that liquid inside. That must be at least 100 degrees Celsius. Look at it. 100 degrees. Let's look over here. The cracker is still burning. And it looks like we're hiding right behind there. About 65 degrees.
Yeah.
60, 65 degrees. Okay. Well, it's still burning and it hasn't been on as long. And this one over here never really got very high.
A little bit above 50.
Okay, there we go. Focus. Give me a little focus here.
Let's see.
There we go.
How do you work these things?
There we go. About 52. So, and clearly not boiling, though maybe a little bit of steam or condensation on the glass. But this one, look at these nuts go.
Very impressive.
It really is. And it looks like it may have even gotten a little bit past 100 degrees, which is a little odd because when it's boiling it should be just 100. But if I look, maybe I shouldn't rest that on the bottom. I hope I'm not going to break our equipment, Colin.
It's worth it.
Well, what have we learned?
Well, I know that I've learned that these almonds definitely seem to have the most energy. And while I thought the sugary, tasty treats might have a lot, seem to have burned out rather quickly.
Yeah. So I agree. And I think that the evidence that the almonds had more energy was the amount of time, but also the temperature was pretty dramatic. It didn't look as nearly as an impressive flame, but it lasted so much longer and burned so much hotter.
Yes.
So, wow. Yum. Well, Colin, I think we learned a lot today.
I think we did.
This has been a really great experience.
Yeah.
I love science. How about you?
I do.
Yeah. In fact, I think this is about done.
I think so.
Cheers.
Cheers. Science.
Hey, Colin. So I was thinking, if food is energy, or food has energy, then pumpkins are food. And pumpkins have energy, right?
Right.
So, I wonder what happens when you burn a pumpkin. No time.